kind of analysis is required if you want to go in depth or if you want to do some kind of research, because as we all are the researcher here, ठीक है, faculty है, research scholar है, as well as what is that PG students भी है. Okay, so whether you understood or not this thing, yes or no? Just I'll take 1 minute time, sorry. G to the power q. So here g to the power x cube we are getting. So here k1. What is the value of a? G to the power x. So here also we are getting g to the power x cube. So you see that k1 equals to k1. और k1 हम किसने कंप्यूट किया? अटैकर ने कंप्यूट किया, एडवाइजर ने कंप्यूट किया. In similar way, you see that k22 equals to k2. Here also, what is that? B to the power p and c to the power y. So k22 equals to k2. Now you try to think here that यहाँ एक मेरे पास मैसेज है, ठीक है, 1 2 3 4 5 मैसेज है. I have encrypted with k1. टारगेट क्या है मेरा? इसको मेरे को भेजना है, किसको? बॉब को भेजना है, ठीक है. Now Bob received it. Sorry, if adversary received it, तो उसने क्या किया? उसको whatever the message was there, that message is retrieved by doing the decryption करके उसको मिल गया. Again he is encrypting. After encrypting it's sending to what? Bob. Bob ने क्या किया? फिर उसको decrypt करके मिल गया. So in between क्या हुआ फिर प्रॉब्लम? In between adversary ने क्या किया? That same message उसने देख लिया. Whatever the message was sent between the Alice and Bob. ठीक है. So this is basically called the man in the middle attack. And what is the solution for that? I told to protect the man in the middle attack, there is only one solution, that we have to use some authentication protocol or authentication technique. In the same problem, just we have considered, okay, pre-shared secret key. We have considered pre-shared secret key between the Alice and Bob. That SK is the pre-shared secret key. ठीक है. So this pre-shared secret, based on this pre-shared secret key, first they are performing authentication, and after performing the authentication, that you see now in this protocol there is no security attacks. If possible, you try to find it. ठीक है. इसके लिए कुछ security attacks या okay. Now I am coming to the main part, that for the designing purpose. Okay. So for example, this kind of scenario is there. First you try to understand here. Okay. That we have considered what in this architecture, how many things you are observing. What is the first point? Tell me. What is the first point? User is there, right? Okay. After user, cloud server is there, right? Okay. Then gateways are there. Then IoT devices are there. After that, what in between कुछ है ना? Fog nodes are there. Yes or no? So here one kind of architecture I have considered, and in this architecture you see that IoT devices are there. There are several IoT devices. Okay. After that IoT devices through the gateway node, it is sending the data to the fog node. Yes or no? That fog node को भेज रहे हो. So after that fog node, that data is sending to cloud server, and from that cloud server, who is accessing? User is accessing. Okay. So from this architecture, again you take 1 or 2 minute time to understand that in this architecture whether there is a need of authentication protocol or not. चाहिए इसमें? ऑथेंटिकेशन प्रोटोकॉल, यस और नो? किस किस के बीच में चाहिए ऑथेंटिकेशन प्रोटोकॉल? फर्स्ट पॉइंट, यूजर और क्लाउड सर्वर के बीच में चाहिए, यस और नो? यूजर एंड क्लाउड सर्वर के बीच में, ठीक है। नाउ फॉग नोड टू क्लाउड सर्वर चाहिए, यस और नो? ओके, एंड देन अगेन दैट IoT devices to fog node, yes or no? चाहिए? So you see that there is a need of authentication protocol between IoT node to fog node as well as fog node to cloud server as well as cloud server to user. चलो मैंने तो authentication कर ही लिया, ठीक है? Now the next question is whether there is a need of key exchange protocol or not. ठीक है, यूजर और क्लाउड के बीच में की एक्सचेंज प्रोटोकॉल चाहिए, यूजर और क्लाउड के बीच में। What was the main purpose of the key exchange protocol? To exchange the key, right? हम की को एक्सचेंज कर रहे हैं। So यूजर अगर फॉर एग्जांपल यूजर वांट टू एक्सेस द डेटा फ्रॉम द क्लाउड, हाउ ही विल एक्सेस? कैसे वो एक्सेस करेगा? वो डेफिनेटली एनक्रिप्शन डिक्रिप्शन चाहिए, यस और नो? अगर फॉर एग्जांपल हम एसिमेट्रिक की यूज कर रहे हैं देन देयर इज नो प्रॉब्लम, बट व्हाई वी शुड नॉट प्रीफर एसिमेट्रिक की क्रिप्टोग्राफी? बताओ मेरे को। क्योंकि उसमें कंप्यूटेशनल क्या हो जाता है, कॉस्ट ज्यादा हो जाता है। फॉर एग्जांपल RSA कंसीडर करो या ECC कंसीडर करो या रबिन या एल्गेमार जो भी है, तो जो उसको कंसीडर करो उसमें क्या हो जाएगा, कंप्यूटेशन कॉम्प्लेक्सिटी हाई हो जाएगा इन केस ऑफ एसिमेट्रिक की। गॉट द पॉइंट? So that's why we used to have a symmetric key whenever we have a bulk amount of data, right? तो इसीलिए अगर हम यूजर और क्लाउड के बीच में अगर हम डेटा सेंड करना चाहते हैं विद द हेल्प ऑफ सिमेट्रिक की, राइट? सो की एक्सचेंज चाहिए या नहीं चाहिए बताओ? डेफिनेटली वी नीड ए की between user and cloud server. In similar way, if we want to send data from fog devices to cloud server, whether there is a need of key exchange protocol or not? चाहिए. For example, whatever the data is captured by the IoT devices, that data is also sending. That data is also we are sending to the fog node. There also it is required. So I hope so you understood from this architecture that how many things are required. Okay, और एक चीज तो मैंने डिस्कस नहीं किया. Here for example, IoT डिवाइस में डिवाइस क्या कर रहे हैं, उसके बीच में कुछ कम्युनिकेट करना चाहते हैं. Are you getting the point? IoT devices also they wants to communicate with each other. So for that they need a secure communication. So for that also there is a need of key. I hope you are understanding the need of authentication as well as key exchange protocol. Yes or no? And if we want to design a protocol for this particular architecture, ठीक है, पहले क्या करना होगा? First we have to perform the registration. ठीक है, पहले registration perform करना होगा, उसके बाद फिर we will log in into the system. ठीक है, and based on that things what we can what is that, design a new session key, and that session key will be used for the encryption and decryption. I hope so that whenever you people have used internet banking or some other software, other website where there is a HTTPS, right? Whenever you are typing something at the left side, that below left side, I hope you have seen that ऐसा type का एक sentence. I hope you have seen that establishing secure communication. Have you seen? Yeah. If not, that once you try to see it later, okay, it means that whenever after giving our login credential or login information, that two parties, client and server, they are establishing a new key. Session key मतलब क्या हो रहा है? Every time they will generate a new key, and that new key will be used for the encryption and decryption. Okay. So for this, these are the things that registrations of IoT devices with fog node, registrations of fog node with cloud server, registrations of user with cloud server, authentications between IoT devices and fog node, authentications between user. Want to make this architecture complete secured, then all these things are required. कितना phases चाहिए मेरे को? Registration एक 1 2 3 4 5 6 और एक शायद मिस हो गया इधर. Authentications IoT device fog node between user and cloud as well as
between devices, IoT devices.
Between IoT devices तो एक है, उसके साथ साथ IoT to I think fog, right? ना IoT and fog तो है. Fog to क्या है?
Cloud.
Fog and cloud. ठीक है?
Cloud and user.
Cloud.
Cloud
and user है ना?
Cloud server and user.
User and cloud है.
Cloud and fog.
Just only one thing नहीं है. That fog to server.
Fog to server.
Fog
भी है.
कहाँ है?
That is registration.
So that is registration, but there is no authentication and key access. ठीक है? वो भी मेंशन करना मैंने भूल गया. और या
वो आर्किटेक्चर में यूजर का प्लेसमेंट ठीक है.
यूजर का
placement
in the sense that it is
architecture.
Yes, it is showing that user is accessing the data from the cloud server.
Directly it is possible.
Not directly,
Because वो nodes मतलब fog या IoT के बाद आना चाहिए ना.
नहीं. Actually here you see that you can, that architecture means what? भाई घर मैंने बनाया, तुम भी दूसरा हिसाब से बना सकते हो, right? The thing is here architecture we have considered that in this way that whatever the data is retrieved by the IoT devices, it is sending to the cloud server. That cloud is doing some kind of data analysis, preparing a new kind of data, and that data is accessing by the user. तो user के साथ ऐसा कुछ relation नहीं है IoT के साथ या fog के साथ, ठीक है? But if you want to make, sir, why should I see that the cloud from the data from the cloud server? I want to see the live data or real time data. Then what? You have directly access to sensor. क्योंकि जब भी वो क्लाउड में जा रहे हो तो रियल टाइम तो नहीं हो रहा है ना, नहीं हो रहा है. Then you see directly access to the sensor. So that different kind of architecture you can propose and you can design. Okay. But here one thing you tell that what is the need of fog nodes? Fog node का क्या काम है यहाँ? क्या काम है fog node का?
Data kind of cluster manager kind of.
हाँ?
They are managing the data received by the IoT cluster, IoT devices.
For example, fog node नहीं है, then क्या होगा?
Overhead managing.
हाँ.
Overhead managing is a point. Okay. Yeah. Comparatively, you think majorly that overhead managing. For example, बीच में fog node नहीं है, तो directly communicate किसके साथ करना होगा? Sensor to server, that cloud server. तो उसके लिए cost क्या हो जाएगा? बढ़ जाएगा. Although that sensors are internet enabled, but definitely to send and data, definitely there is a need of energy. Yes or no? मैं अभी बात कर रहा हूँ ज़्यादा, तो मेरा तो एनर्जी जा रहा है, कंज्यूम तो हो रहा है मेरा. तो सेंसर का भी क्या होता है, उस हिसाब से डेटा जब हम सेंड करते हैं या रिसीव करते हैं, so for that also that sensor needs some energy, and for that latency is high if there is no fog device or edge computing or edge devices. Another thing, ऐसे भी कर सकते हैं, और भी एक कुछ एडवांटेज हो सकता है that fog device में जो भी डेटा रिसीव कर रहे हैं by the IoT device, उसमें कुछ पहले ही मैनिपुलेट कर रहे हैं, क्योंकि IoT device क्या कर रहे हैं, they are taking the raw data, उसका और कुछ काम नहीं है, उनका एक ही काम है, just you take the data and you send to the fog. ठीक है? फॉर एग्जाम्पल फॉग नहीं है तो डेटा को ले रहे डायरेक्टली कहाँ भेज रहे हो, सर्वर में भेज रहे हैं, तो अननेसेसरी बहुत सारा डेटा को वो भेज रहे हैं. सो दैट इज बेसिकली द रिडंडेंट फॉर दैट ट्रैफिक विल बी हाई and some many kind of problem will be there. So I'm not going in the network description. Okay, so here you see that if you want to design, here we can use very simple, and already you know that the hash function. We'll use hash function. Hash function का क्या काम है? What is the use of hash function? ये hash function है, उसमें जितना इनपुट देना है दे दो, बट वो क्या करेगा, वो इसका एक फिक्स साइज आउटपुट आएगा. Like for example 0,1 to the power star to 0,1 to the power n. ठीक है? So that is basically the main for the what? Hash function. XOR operations already you know. Another operations I have mentioned here, that physically unclonable function, एक POP function. ठीक है? Anyone is from hardware security? Hardware? sorry, what is that, electronics background? Anyone is there? Yo. So I hope maybe you have that physically unclonable function, that this is basically the circuit. Okay, if you are asking any question for this from here, that I can't answer. Okay, because this is completely related to GC, but what we are using here, PUF, what does it means? That PUF, right? And based on that input, it will produce a response. Okay, it will produce a response. And you see that unclonable, इसका एक हम सिमिलर कॉपी नहीं बना सकते, इसका सबसे बड़ा सिक्योरिटी में यूज हो रहा है आजकल, क्योंकि ये क्या हो रहा है, ये बहुत लाइट वेट फंक्शन है। हम लोगों का क्या टारगेट था? लाइट वेट टारगेट था। लाइट वेट के लिए कौन सा फंक्शन हम यूज कर रहे हैं? फिजिकल। फॉर एग्जांपल एक इस टाइप का फंक्शन मैंने बनाया, इस टाइप का फंक्शन मैंने बनाया, एक फंक्शन बनाया, इसमें मैंने इंस्टॉल कर दिया इस मोबाइल में, ठीक है। ये बोल रहे हैं अगर इस मोबाइल में हम करना चाहते हैं तो दिस व्हिच इज नॉट पॉसिबल, मतलब सेम टाइप का नहीं हो सकता। फॉर एग्जांपल एक मैंने डिजाइन किया, इसमें इंस्टॉल किया मैंने, ठीक है, और एक मैंने डिजाइन किया, उसमें इसमें इंस्टॉल किया। इसका जो चैलेंज है, दिस चैलेंज एंड दिस चैलेंज आर सेम, बट विल गेट ए डिफरेंट response, right? So that is basically the main beauty of the physical unclonable functions, and that's why whenever there is a security related, especially in IoT and sensor, okay, they are using physical unclonable function. Okay, now these are the security attacks we have to protect whenever we will design a protocol. What is that? Password protection. How to protect the password? For that we have to use impersonation attack. Okay, so impersonation attack also should be protected. मतलब ऐसा नहीं है जो I am a legal user, on one behalf of me some other user is logging into the system. Are you getting my point? So that is basically called the impersonation attack. Okay, then inside an attack already I told. Okay, now then next is session key security. I hope I should also discuss something, that key point of view. I hope already you are having a knowledge of public key, private key, secret key. Okay, there is another new there is another key that is called the session key, and this session key is called the temporary key. Okay, temporary key. But the thing is, we have to provide, still we have to provide a security. Why? ये तो भाई टेम्पोररी, हम 5 मिनट में काम करने के बाद अगर कुछ हो जाता है, no, it's not like that. For example, today you are using one session key or say on session key. If this key is being disclosed in future after 2 months, there will be a big problem, because based on that session key, whatever the protocol description is there, they may compute the previous session key. Okay, so if they are computing the previous session key, whatever the message you sent earlier, all that message will be public, and that will be computed by the adversary. Okay, so that's why we need the protection of the session key security. Okay, replay attack already you know. Okay, if you are replaying the message, okay, just to make the busy to the server, so that is the replay attack. Then DDoS attack, anonymity, that means we should, in some system, okay, we have to protect the anonymity also. We should not disclose the identity. Okay? So for that also we have to use a technique, perfect forward secrecy. What I told you, that today I am using one session key, that session key should not be disclosed in near future. If it is disclosing, maybe whatever the previous data are there, that all the data will be public. So perfect forward secrecy, compromisation problem. What I told you, I think that for example, drone is compromised or IoT device is compromised. Okay, server side issues. Server side issues is also very much dangerous. We will design, we should think that our personal information should not be stored in the server side because of the trust issue. ठीक है, बिकॉज ये ट्रस्ट इशू बहुत बड़ा प्रॉब्लम है, बिकॉज इफ यू आर स्टोरिंग सम confidential information at the server side, they may disclose it also. Although नहीं होता है, but मैं क्रिप्टोग्राफिक और साइबर सिक्योरिटी पॉइंट ऑफ व्यू में बोल रहा हूँ, बिकॉज वी ऑल आर इतना बड़ा आदमी नहीं हो जो हम लोगों के ऊपर कोई अटैक करे. हम लोगों के पैसे भी नहीं रहते हैं और कुछ भी नहीं रहता है, ठीक है. इफ इट इज देयर विद सम अंबानीज फैमिली, ओके, और सम अदर दोज हु आर हैविंग ए मनी, बिकॉज हम लोगों के पास रैंसमवेयर अटैक कभी फेस किया तुम लोगों ने? नहीं किया. क्या है, इसलिए बिकॉज हम लोगों के पास ऐसा इतना बड़ा ऑर्गेनाइजेशन भी नहीं है और हम लोगों के पास पैसा भी नहीं है, ठीक है. बट रियली आई एम टेलिंग यू, वंस यू गो थ्रू इट इन गूगल आल्सो, you will see that big organizations that they are suffering from this ransomware attack, because they are having money. If they are trying to encrypt the documents, they will earn money, okay. So these are the things that server side issue, okay. Now you see, like, that's why I have given that example, that Diffie-Hellman key exchange protocol, where we have seen that some kind of crypto equation. So these things will achieve only with the help of क्रिप्टो इक्वेशन, ठीक है. इस क्रिप्टो इक्वेशंस के बारे में हम सिर्फ उतना डिटेल्स में हम नहीं बता पाएंगे, बिकॉज इट विल टेक 3-4 आवर्स, ठीक है. बट हाउ दे आर कैलकुलेटिंग, व्हाई दे आर कैलकुलेटिंग, दैट थिंग्स आई विल टेल, बट एंड आई विल शेयर दिस स्लाइड्स, ओके. देन यू कैन गो थ्रू इट लेटर आल्सो. सो द फर्स्ट पॉइंट इज IoT डिवाइस रजिस्ट्रेशंस विद फॉग नोड, ठीक है. सो हियर चैलेंज रिस्पांस पेयर they are using, and then computes ZK equals to H of FID. FID means that identity of the fog node, okay, and RK. What is RK? RK is the response from the challenge, okay. Stores IDK, ZK encrypted using RK as key and CK stored in the plain text form. Where it is doing? We are doing it in the IoT devices, or we can call it as some sensors also, ठीक है. In similar way, ये चीज करने के बाद जो जेड का जो वैल्यू है, इस जेड के वैल्यू को हम कहाँ सेंड कर रही है? फॉग नोड के पास सेंड कर रहे हैं. एंड फॉग नोड क्या कर रहे हैं? आईडी के एंड जेड के को स्टोर कर रहे हैं, ठीक है. एंड दिस थिंग्स डेफिनेटली whenever this value is sending IDK and ZK, definitely it should be in offline mode or through a private channel, so that the value of ZK should not be compromised or should not be disclosed. In similar way, fog node भी क्या कर रहे हैं? रजिस्ट्रेशन कर रहे हैं. किसके साथ कर रहे हैं? क्लाउड के साथ. That he is also performing, you see, that same kind of, what is this H? H means a hash function. This hash functions, and then it is storing FID and this FJ. In similar way, registrations with the cloud server. In case of registration, यूजर का अगर रजिस्ट्रेशन करना है तो क्या चाहिए यूजर के लिए? हम लोग जनरली क्या आइडेंटिटी चूज करते हैं और पासवर्ड देते हैं. कभी कभी एक फॉर्म फिल भी करना पड़ता है, भाई बर्थडे, डेट ऑफ बर्थ डालो, दिस सो मेनी थिंग्स. सो हियर वी आर चूजिंग जस्ट फ्यू थिंग्स, दैट आइडेंटिटी PWI TIDI and a random number, then it's counting total number of challenge response pair, then it's computing value of AI with the perform of XOR operations and store this value AI, TDI, TID, RI and CI in the memory of either mobile, because either we have to log in with the help of mobile devices or with the smart card also, okay. So we can store that data or that parameter in the smart card, and these are the value we are sending to the cloud server. Cloud server is also storing some information. You see, whatever the information is storing by the cloud server, for that there is no issue, there is no personal information of the user. We have to think whenever we will decide. Now authentications and key agreement between that IoT devices and fog node, okay. तो इसके लिए भी देखो कितना सारा equations I have written here. If I am telling all these things, you will not understand. Very frankly, I am telling you, don't take it in a negative way. But we have to think all the equations in details, and for every equation there is a meaning. For example, here you see T double dash minus T dash something, some timestamp. Some timestamp, that verifications they are doing just to protect the reply item. If they cannot protect the reply attack, then protection of DOS attack is also difficult, because that DOS attack is generating based on the reply attack. ठीक है? इसमें से देखो कहीं पे भी we have used, okay, this is fog node to IoT devices to fog node. You see that ZK was stored in the what is that sensor node. Okay, यहाँ तुम ZK को देखो कहीं पे भी वो as a XOR function use नहीं किया. Always it has been used inside the hash function, because hash of A comma B, hash of A comma B. Can you find the value of A from the message digest? No, because 0 comma 1 to the power star to 0 comma 1 to the power n. If you are giving the value of 0 comma 1 to the power n, you cannot compute the value of 0 comma 1 to the power star. So backward is not possible. So that's why we are putting over here. Okay. So in this way they are authenticating each other, and finally you see here what is SK. This SK and this SKF. You see both are same. It means what? It's a session key, and this session key will be used to transfer the data from what? IoT devices to fog node. Okay. In similar way, you see fog node to cloud server. Some other parameters we have calculated here. SKFN to SKCS. What the point? So here also that they are generating a new session key, and based on this new session key, whatever these things are there, you see that checks if KJ dash equals to KJ, authentication authenticates CS. That means control server or cloud server. Okay. So based on that we can perform the authentication as well as we can perform the session. Okay. So these are the things that I'll request you to go through, because I'm not going in details and in depth also all this crypto equation. Okay. So you will go through it. So this type of protocol, that after designing, the main part is the security analysis. Okay. So we have to do the security analysis or security validation, because if you are not doing that security validation, okay, then how will you ensure that your protocol is, or the attacker cannot do any kind of attack on your protocol? So for that we need a security validations or security analysis. If we want to do that, these are the three techniques: informal security analysis, random oracle model, okay, as well as some simulation things are there. This is basically that informal security analysis. This informal security analysis means under some hardness problem. जैसे hash function का क्या hardness problem है? Hash function से क्या हो रहा है? We are getting the forward direction, but we are not getting backward. That means from the message digest we cannot calculate the original value. Based on that consideration, that these are the attacks are protected. For example, if you are considering password attack, इसमें देखो IDI, PW and RI, तो इसमें से password कोई retrieve नहीं कर सकता. No one can retrieve the password. For example, you can consider here that man in the middle attack. Man in the middle attack. So if someone wants to perform man in the middle attack, the attacker should know the value of RI and AI, which are unknown from the protocol description. So that's why the attacker cannot execute the man in the middle attack. In similar way, IoT device capture attack. Whatever the value we have stored, we just try to think the interesting thing that in here ZI कहाँ which is ये जो ID के and ZI जो है ना, उसको ऐसे ही हम IoT डिवाइस में स्टोर नहीं किया. उसको मैंने उसी हिसाब से स्टोर किया है that you see it is in encrypted form. IDI and ZK. और किससे उसको एनक्रिप्ट किया है? RI से एनक्रिप्ट किया है. For example, उस IoT डिवाइस कैप्चर हो गया, ठीक है? अटैकर ने उसको ब्रेक भी किया है और उसको ट्राई टू गेट दैट circuit also, pop circuit also. Due to the unclonable property, the attacker cannot design the same kind of circuit. So the response, he cannot decrypt it, and as he cannot decrypt it, he will not get the value of JIT. Okay. So that kind of techniques that we have there. After that, so this is basically that the informal security analysis. Then you come to the simulation part. So you may use, these are the simulator like ABISPA simulator, Prof simulator and CITER simulator. Individually, that's all simulators are having their different objective. Okay, जैसे ABISPA simulator वो मॉडल चेकिंग करता है, साइथर भी मॉडल चेकिंग करते हैं, प्रोवेरिफ थोड़ा सिंबल के ऊपर काम करते हैं, राइट? एंड व्हाट इज दैट? This is for protocol representations, HP, HL, PSL code we have to write. For CITER, SPDL code. So these are the three popular so far. But out of these three, I will suggest that CITER is the best one nowadays. So people are using the CITER tool. Okay. So that's why I have considered here CITER. So this is the process to. So this is the process to install the CITER, and this is basically the CITER tool. So what is the meaning of the CITER tool? CITER tool is telling, for example, in the previous protocol, what you saw in the previous protocol, there are several crypto equation. IoT device A compute कर रहे हैं, what is that? Server compute कर रहे हैं, fog node compute कर रहे हैं, right? So we have to write the role based code for the CITER. ठीक है, और जितना पैरामीटर है उस पैरामीटर से क्या हो रहा है, कुछ पब्लिक पैरामीटर, कुछ प्राइवेट पैरामीटर. तो जो प्राइवेट पैरामीटर है एज पर योर अंडरस्टैंडिंग और एज पर योर कंसिडरेशन, राइट, आफ्टर द एग्जीक्यूशन whether the same parameter are private or not, that things will ensured by the CITER. ठीक है, so whether the public private informations are still private after execution the protocol, that will ensured by the CITER code, and this is basically the sample of the CITER code. Okay, here we are checking, you have seen that claim IOTD secret REI1. तो ये REI1 जो है ना, ये मैंने प्रोटोकॉल में चेक किया था, प्रोटोकॉल में मैंने सीक्रेट एज्यूम किया था, जो ये सीक्रेट इंफॉर्मेशन है, ठीक है. After executions also we are checking whether this parameter is secret or not. You see that SKI, here also SKJ, ठीक है. So all this session की means what? It will be private only. So after the executions whether it is secret or not, that we are checking, okay, with the help of this CITER. So and this is basically the result. Whatever the checking was done, so value will be written and it will check you whether it's okay or not. And if there is some security attacks in your protocol, it will tell you that this is, that means instead of okay, it will show some red color over here, and it will be mentioned that attack bounded. Okay. So this is a CITER result. After that, this is another simulation, that is with ABISPA tool. So here also we can write some code, and this tool will be really, I am telling you, very, very popular for the research work purpose. If you are interested and working in any kind of designing of protocol or some any related kind of work you are doing, definitely you should use. Okay, this ABISPA also. In ABISPA, it's telling that, you see, this protocol is safe or not. Okay, this protocol is safe or not. Okay, so from this ABISPA we can know. So this is the result. This is basically that we have claimed. Okay, whether that private information are kept private only after the execution. This is the performance analysis. Performance means what? Whenever we are calculating or writing, designing some protocol, so that time we have to check how many hash function or how many encryption, decryption. So based on that, we can calculate some computation cost. Okay, so this is basically the computation cost, and this is basically the communication cost. That means how many bits we are sending from one person to or source to destination. Okay, so this is basically indicating the performance. So this is basically the another use cases. I thought that we'll be discussing in details just after discussing all these things. So if this kind of scenario is there for you people, okay, then what kind of thinking will be there for you, that what kind of security attacks are there, how many phases will be there, and where we need authentication, where we have to provide a key exchange. For example, here you see that architecture is little bit different. Okay, here sensor is there, here gateway node is there, here user is there. Okay, sensor is sending the data, it is sending to the gateway node is sending the data to the user. Now the thing is, if this gateway node, this sensor is doing the registrations with this gateway node, but wants to communicate with this sensor node. Are you getting the point? Okay, then for that, what kind of protocol we have to design? So several combinations are there. So that combinations we may explore, or you people may explore in near future based on whatever the things I discussed from last beginning to end. Okay, so this is the use case. And the last part, I think you all are waiting for this slide, that conclusion. Okay, so these are the things I have discussed. Now you tell me if you are having any doubts. I'll take some question. Okay.
Sir, in performance analysis, like while calculating computation and communication cost, there is a table in which it is written for hash value this per seconds. So how to define those?
Yes. So that is for that. For example, you may also do, no problem. For that, you should have some computations that some system you are taking, you are implementing SA1 or SA2, whatever you are using. Okay. So for that, you can take whatever how much time it is taking. Okay. For example, sensor point of view, to connect with the Raspberry Pi. Okay. So you write the code for in the Raspberry Pi, then you will get that percent how much second it's taking to compute by a particular sensor. Okay. Because you see that if you are using a high computation system, it will take definitely a little bit less. ठीक है, तो उस हिसाब से वो करते हैं, बट ये सारे रिसर्च पेपर में रहते हैं, एक स्टैंडर्ड माना जाते हैं, तो इसको हम लोग एज ए कैन कंसिडर इट एज ए
In the field. With an impressive portfolio of over 60 published papers and more than 100 expert talks delivered across various forums, his numerous accolades, including the Young Scientist Award in 2017 for his contributions to PetriNet theory and the prestigious awards for ADG, Delhi, DTE and NCC Achievers in 2023, underscore his excellence and dedication to research and academia. Please join me in extending a warm welcome to Dr. Karan.
कोई बात नहीं, जो हमारे पास आ गया नहीं पढ़ाया होगा, कहाँ से आ गया कहीं से लिया होगा.
Anyway, I'm not told.
It will be linked.
Never. किसी का आ गया होगा.
किसी की पहली लाइन रह गई होगी. He is assistant professor in CIS, School of Computer Integrated Science, which is exists in JLU. मैं आ रहा हूँ जरा छोड़ के सबको छोड़ दो.
This is fine. Visible to all of you. Okay. Very good evening to everyone. You can come front. You can sit. Everyone can sit. And all of you from Delhi or outside Delhi?
Outside Delhi.
Outside Delhi. From where?
Faridabad.
Faridabad. Computer science department.
EC.
EC. And
Great University, sir. Samudra University.
आपको मैंने कहीं देखा है.
सर मैं जेने में आती रहती हूँ.
आप लोग?
सोनीपत. निफ्टम.
नेफ्टम कुंडली सोनीपत.
प्रयागराज.
Prayagraj? And you?
So JNE.
You also did.
JNE.
Both of you? Fine. So basically, algebraic graph theory and the PetriNet cryptographic system. Subtitle you can say how we can use graph-theoretical approach and the PetriNet approach, or how we can optimize with the help of graph theory and PetriNet algorithm. Okay. also how we can simulate after modeling the complex system. That is something basically. So first of all, we must know what is the algebraic graph theory. You know the algebra. We will use the algebra, and you must understand graph theory. It is not the graph of the function. It is different. It is not similar with the calculus graph. Okay, here graph is different as from the graph from calculus. In the calculus, we have some function, we plot, we take some point x and y, and we plot the graph give2d of the function 3 variable, 3d or 4d, and similarly n variable we can plot. Okay, but here the flexibility is that we have number of vertices and connectivity between the vertices, some nodes. Okay, and these nodes we can join directly, or we can join by a Jordan arc. You know what is the meaning of the Jordan arc? Means you can join any way. You can take any path, or directly, or any zigzag way. Any way you can join. That is a graph basically. It is independent of drawing basically. Suppose we are here, all can be treated as a vertices. Okay, and you can hear my voice. Everyone, that means we are connected to each other. Maybe directly, maybe zigzag, up to you. That is the concept of the basic concept of the graph. And the concept of the graph theory, it is as pure as just like a pure mathematics. Also as applied as just like applied mathematics. You can do just like work as a pure mathematician, okay, or practitioner or theoretician. We can connect. Both are related to each other. And till now, I'm not able to find even a single area where graph theory not applicable. In all the areas, electronics, electrical, bioinformatics, life science, social science, all kind, even the linguistic or and the literatures, directly, indirectly they are using the concept of the graph theory. Very, very applicable. Very, very applicable. Okay? And due to its abstract nature, also the applicability you can use in cryptography system and coding theory, in lattices, fine. And here you can see algebraic term. Algebraic means, under this means we use the concept of the algebra. Okay, means group we can use, ring, field, vector space or linear algebra. We use the concept. Also we use the matrix concept. Every graph can be converted, can be represented in terms of the matrices, and every matrix we can plot the graph for the given matrices. We can plot, always plot for the positive integer. Even right now, we are able to plot in the real numbers graph. That is also possible. Fine. You know the graph group. What is a group? Everyone knows about the group.
Same property.
Some property follows.
Properties associated,
Closure property.
Ring.
Inverse. Okay. I'm assuming you know that basic concepts. Okay. So now, this is some outlines. Okay. First, I'm giving some flavor. Then we will start the concept of the pastinate. Okay. And if you are good in programming, then definitely you will be able to do the modeling, and also you can produce a good quality. Definitely after the talk, or I can, or you can initiate after some understanding the basic concepts. Okay. To first understand the basic concept, here the key concept in the algebraic graph theory, adjacency matrix, means how you can consider the adjacency matrix. Suppose you have two vertices. If they are connected, write one. If they are connected multiple way, more than one edge arcs are there, you can join the number of arcs or edges are connected. You can write that weight or number of edges to the connected with a pair of vertices. Okay? V1 to V2, we have three connections. Three connection means suppose you are the node, I'm also a node. You can be my brother, you can be my friend, you can be my colleague. So three ways are more than and one ways. Number of ways you can write number. In this way you can form the adjacency matrix. Okay? And remember, once you have adjacency matrix, and if you calculate the power of the matrix, nth power, So here I'm going to tell you the interpretation of the nth power of the adjacency matrix. Understand? Suppose you have 2 power, 3 power, 4 power if you calculate the adjacency power. Okay? Fine. So what does that mean? Suppose you have a to the power 4, some AGI entry. Okay? So what is the meaning of that that entry? That the kth power in the adjacency matrix from the vertex I to j, that represent the total number of walks. Total number of walks. You can find easily. One vertex to I vertex to j vertex, if you have fifth power, okay, fifth power means of length 5, that entry, that is suppose 10, ijth entry is 10, it is in the bracket in the matrix. So that means that entry represents the number of walk of length k, okay, that particular entry. So you can find all possible number of walks. So you can choose which is optimal, which is related to your that is the applicable, very fundamental application of the matrix, power of the matrices. You got my point? Next is the degree matrix. Degree means it is the adjacent, it is a diagonal matrix, and each diagonal entry represents the degree. Degree means number of edges connected to that vertices. Suppose in that class you have 20 participants we have. My degree is 20. My degree is 20. Number of connections. If there is no connection at all, the degree is 0. Is that fine? Similarly, Laplacian matrix, you can form degree matrix by adjacency matrix. Okay? Once you have Laplacian matrix, you can find or you can also consider spectral. You can use the spectral means from this you can find the eigenvalue, eigenvectors. Okay? You know how to find the eigenvalue and eigenvectors for the given matrices, square matrices. Okay? Whatever the lambda x equal to lambda something, you can use this. You can find the eigenvectors. Okay? And if you have the largest application, I want to tell you the other application. If you have the maximum eigenvalue, okay, maximum eigenvalue can be used in taking the decision making. Maximum eigenvalue. Although there are several methods to find the maximum eigenvalue, it is not easy. Suppose if you have the higher order matrices, 20, 30, it is very difficult to find the whole eigenvalue or 100 even. It is very difficult. Okay, maybe you can use your programming skill, but if you increase the power, let us suppose 1000, 2000, okay, so it is very difficult. Okay, but still there is scope of the research because it has a significant interpretations, right? This is some application. Eigenvalue adjacent matrix gives insight into the graph connectivity. You can draw some informations. If your eigenvalue, what you can conclude, clustering you can use, and also connectivity. Okay, and eigenvalues, Laplacian matrix, you can study the expansion, partitions, several things you can study. Okay, and graph isomorphism. What do you mean by graph isomorphism? Means with the help of graph, we check whether the graphs are same or not. Okay, because whenever you have connections in maybe the computer science, maybe the electronics, you connected some nodes or some particular junction by your wiring. Okay, wires. If some wiring is there, you are connecting. Several wires of connections are there. Okay, so in that case, which network is same? Only you can know. You can check. Only the concept is which is called the isomorphism. Okay, I can draw one figure here if you want. Let us suppose I'm drawing, this is the thing I'm drawing here, let us suppose. Okay, I'm drawing this. Fine. And similarly, I'm taking something else here, like this, and here, I'm joining by this, or joining this and this. Okay? Understand? This is a very simple example. Can you tell me which bone graphs are equal or same or not equal? Equal है? Both are equal?
Yes, sir. Yes, sir. Yes, sir. A not that connected to each one.
So how you will check?
Degree.
No.
Alpha
Only the isomorphism.
Alpha.
Only the isomorphism. Okay? Remember, when the graphs are isomorphic, number of edges, number of vertices, and number of vertices of the same degree, that is true. Okay? But converse may not be true. Remember. If you have the same number of vertices, same number of edges, and same number of vertices of the same degree, graph may not be isomorphic. I can give you one counter example. Okay? This is a here. This is, and one is here, one, let us suppose this is, and how many vertices it has? 3, 4, 5, 6, 7, 3, 4, let us suppose this is the, okay. So now you can check in both the graphs. How many vertices in both? First one?
7 both.
7, okay, fine. How many edges?
7.
6. 6 edges? Okay. Same number of vertices of the same degree, you can check here. How many vertices of pendant degree here? Okay, yeah. Okay. You can have one more here, like this. Okay. Okay. My concern is, if you have same number of vertices, same number of degree, or same number of vertices, same degree, graph may not be isomorphic. My concern is that. Okay. If the graph are isomorphic, okay, in that case both cases are this number of vertices, edges, and same number of vertices of the same degree. That is true. Always true. Fine. So you can use those concepts in your coding theory in the cryptographic way. Where codes look like different, but if you check the isomorphism, whether the code is same or not, or you can use as a encapsulator and decode it. Encode and decode, you can use that concept. You got my point? It can be used. Okay? Similarly, graph and connectivity means one applications, connectivity system, networks, public key, we will discuss in, I will give you some example later on, but this is some overview about this topic. You just see it only, sub applications, fine. So here also we will some other highlights, graph representation, optimization key, graph problem, graph algorithm, various field, limitation. Okay. So now I'm coming here because I'm trying to integrate graph and net. Okay. Then we will use those concepts in generating the lattices, and we will try to apply it in diversity, not one diversity. Okay. You can also start your work if you love this subject after that. Okay. So here I'm talking about the net. You know the concept of graph theory. What is this? Connectivity between dash, and how you will define the graph. Graph is equals to V comma E. V is the set of vertices, and E is the no set. E is the unordered pairs of distinct vertices. Mathematically, that is the definition. Unordered pairs of distinct vertices. Unordered pairs. Okay? Unordered means if you join A to B or B to A, same thing. Okay? But if you say it is a collection of ordered pair of distinct vertices, that is a digraph, or this is called the directed graph. If you say directed ordered pairs, okay, and G equal to V comma E, if I write like this, G equal to V comma E, okay. So here edge set can be empty, can be non-empty. Okay, if it is empty edge set, only you have number of vertices. Okay, then the graph is called totally disconnected graph. Totally disconnected graph. No connectivity at all, but graph will exist. Okay, for example, you are here. I'm assuming that nobody knows each other. कोई भी किसी को नहीं जानता, but existence is there. Okay, understand? So after the 10-day workshop, maybe everyone knows, or you become the friend. Everyone friend become everyone. So that is called the concept of the completeness. That graph is called the complete graph. Got my point? 10 vertices and every person has 11 friends. इससे कुछ छोड़ दिया जाए. Okay. So now that is the concept of if E is empty, graph is called totally disconnected. Okay. And if the set is finite, graph is called finite graph. If the set is infinite, then the graph is called infinite graph. Is there any example of the infinite graph? Any example? Yeah, any example? Your web network also. Okay. Also the grid structure. Let me see it here. Grid structures. Grid graph. These are the nodes and so on increasing. Okay. Understand? So vertex is also infinite. Edges also infinite. Infinite, not a number. It can be anything. Very large number of vertices, large number of edges. Okay. And the number of edges are called size of the graph. Remember. Okay. And the number of vertices are called order of the graph. You got my point? Okay. So that is a basic definition of the graph. So now I'm coming here, the petri net. Okay. Petri net is the directed bipartite graph. Okay. Directed bipartite graph, how you will define the concept? That means I can split the number of vertices into two disjoint subsets. For example, vertex set here, edge set is here. I can split the number of vertices, two disjoint subset V1 and V2, which is non-empty, which is also non-empty. For example, in this class, one set is girls, or female or male, female. Second set is male. I partition the whole class. Whole class means we have n number of vertices, n number of participants. Okay. What I'm doing here, what I did here, I separate. I have put female in the one subset, or I can say female are sitting that side, male are sitting that side. Simply. Okay. My assumption is that female cannot interact with each other. That is my assumption. You cannot talk with each other. Similarly, man cannot talk with each other. Okay. Man can talk. Man can make the friend female as many n, more than one. Similarly, female can make friend, or may discuss or may interact more than one male. Got my point? There is no connectivity within the subset. Okay? So creates or assume such kind of scenario, or you can use in your research if it is there. Okay? So here, this is the graph. That graph is called bipartite graph. This graph is called bipartite graph. Okay? Similarly, we can partition the vertex set into n number of subsets. That graph is called n-partite graph. Okay? So petri net is nothing. It is a directed, means direction is there, directed bipartite graph. Is that fine now? There is a one more additional condition. That condition is called the marking. That is why it is very much popular nowadays and can be applied in almost all areas. The concept of the petri nets. The additional condition is called here, that condition is called the marking. I will give you the example. Definitely. Coming 4-5 slides after slides. Okay? You understand the concept of the petri net? The idea, you can see original idea in 1962 in the thesis of Carl Adam Petri. The concept given by the Carl C.A. Petri. Okay, and whenever he was at the age of 13 years old, he produced the chemical model. He applied that concept in the chemical to designing the or modeling the chemical process basically at the age of 13. And in 1961, he has submitted a thesis to Darmstadt University, Germany, Darmstadt University. In 1962, he has defended, and after that, more than 1 lakh paper has been published in various areas of the sciences and the social sciences as well. Onwards. Okay? So what is the petri net? Petri net is a directed bipartite graph. Okay? And it is also a discrete event driven system. Discrete event driven system also. Okay? And also we can use as this petri net concept as a machine learning. We can use that concept as a machine learning. You can also use the concept of data science, artificial intelligence. Actually, it is a one kind of tool basically. For the computer scientist, it is a tool, one kind of tool. And for the mathematician, it is just like as pure as just like abstract algebra or the real analysis, as pure as. Okay. So now, why we use the petri net? Because we know our biological system, our body system, astronomical system. These systems are, or even the computer science system, very very complex. Not easy to understand, or you cannot visualize it. You cannot see by your naked eyes. It is very very difficult. Okay. But here, if you start your process with that petri net, you will get some possible number of states. If you have some possible number of states, you can start your work. Okay, and after that, several techniques you can use from the optimization. Heuristic also technique you can also use to optimize your model or your programs. Okay, so that is why reason is that these systems are very very complicated. In that case, ordinary graph theory you cannot use, but here, if you use the petri net concept, you will be able to generate all possible number of states, even the exponential power state you can generate if your machine allowing you to for the computation. Okay. So here, that is a concept I already discussed. Several variations are there because in various time zone, various requirement. Okay, authors giving the several definitions. This is some chemistry here. And then Patil, Rinskill, Jensen, Murata here. Okay, but I will use only one definition. That is definition I have taken from this article written here, Jensen. Why I choose that? Because this definition is in the form of the matrix, and I thought and I feel that the matrix definition can be the much more operative. That is why I have chosen that definition. You can use any definition. I am giving you the formal definition of the Jensen definition. Another diverse application you can see. Okay, before that, this is a pictorial representation of the petri net. Okay, because I told you these are the elements of the petri net. Because petri net means it is a directed bipartite graph. Okay, it has two kinds of node. The one kind of node is this. This is the one kind of node. Okay, this is called here boxes with transition. Transition. Okay, whenever you model your system, your proposed system or any complex system, whenever you have activity or any kind of action, that activity or action you can denote with the help of the transitions. Okay, any action, any work like this for any activity. And circle means that is called here place. We have two kinds of nodes, circle and transitions, boxes. Okay, that means this is called the place. Place you can denote wherever you have the condition or whenever you have some stable things. Okay, that you can take as a place node. For example, class state, that can be taken as a place node. Okay, and dot means dot represent that is called the token inside the place, not the boxes. Because place is a stable things, you can accommodate so many things inside the place. Similarly, this is the room. You can accommodate several participants as per the capacity of that room or sitting plan of that room. That is number of token, or that represent the presence of particular resources or availability. That is the interpretations by modeling. Okay, and arrow represent the, if you connect place to transition, that is the direction, or you can say it is a positive and incident function. You can connect place to transition, similarly transition to place, but you cannot connect place to place. You can connect place to place by a transition or transition to transition by a place, because it is a directed bipartite graph. Directly you cannot connect. Right? That is a formal definition I have taken from that the Jensen article. It is a 5 tuple. I am using the basic concept of the, he has used the basic concept of the algebra. Okay? Set of places, transition, it is empty, and this is negative. I mean a negative incident function means the arc from place to transition. I plus means arc from transition to place. And for every place, there has to be transition. And for every transition has to be place. I cannot leave place or transition isolate. If place is there, transition must be connected. If transition is there, place must be connected. Okay? Understand? place transition connected one element or another subset, that is possible. That means this situation is possible. This is the place. This is, let us suppose this is transition. This is possible, allowed. But if I say like this, or this is the place and transition, I am not connected. This is not possible. This scenario. Okay, that means disconnected pettinat is possible. Okay, but I cannot leave without connecting a place or transition by the definition with this condition. This is the function initial marking that place can accommodate any number of tokens including 0. Basically, it is a mapping from place to the natural number, means it is a whole number basically. Whole numbers. Fine. You can take some real number as well, because some researchers, they have worked on the real number as well as per the requirement. But I am using a basic concept, basic ordinary pettinat. This is the definitions. Okay. Although in the literature, due to the various applicability, lots of classes are defined by the different researchers. Stochastic pettinat is defined. Time pettinat is defined. Continuous pettinat is defined. Hybrid pettinat is defined in literature. Weighted pettinat is defined. Fuzzy pettinat is defined in literature. Now you can see lot of applications are there. That is why lot of applications. Okay, if you know this area, you can implement. Even you do not have the background, you can do a very good quality of work without knowing much more mathematics. Okay, I will show you the flavor on different area after that. And here, this is a pictorial representation. Here, marking P1, you can see 3 places for transition. P1 no token P2, P1 is P3 is 3, here is 1, and this can be written as 3, 0, 1. Now, we are in the vector or linear algebra. Now, every marking can be written in the form of the vectors. So, several concepts of the linear algebra you can also use in your cryptographic way. You can use, okay? So, body marking, if I use this, we wrote this component wise, P1 has 3 tokens, 3 resources, 3 persons, you can say. P2 is absent, no, nothing is that particular room if you take P2 as a room. Okay, I can give you one example. Let us suppose you are using the ATM machines. Okay, ATM machine can be taken as a place node because it is a fix. Okay, and the key buttons on the ATM system can be taken as the actions that can be treated as the transitions. Okay, understand? And the money inside that I'm assuming ATM system is working. Okay, money inside that be taken as the token. Okay, so whenever you enter the particular key button on your ATM machine, okay, that means some condition met. Condition met means there is some kind of firing rule here. I will explain next slide. That activated, transition activated. If you enter the desired number of amount, okay, that moment of a token will deposit to you. You can also take yourself as a place node. So in this way, before the drawing the money, state was different. After drawing the money, state has been changed. So before the filing, there is a filing rule. I will explain in the next slide. So you can check the all possible number of states. Okay, this is for one machine. Similarly, you can model the more than one ATM machine and number of machine you can activate. Models. This is another. Whenever you have the arc of the type P1 to Tj, Pi to Tj, that will be the element of I minus. If you have the arc of the type Tj to Pj, element will be the I plus or positive incident function. Okay, so this is very important filing rule. Any transition, okay, can be fired or enabled. First is enabled. The enabled means if number of arcs from place to transition is less than equal to number of token and in its input place. This should be true for all connected places. If this condition is satisfied, that transition is enabled. Okay, so after enable, you can fire. If the event actually take place, you can file a transition. Otherwise, no need to file the transition. Okay, if the event actually take place, means the new state of the system or updated state governed by this rule. The number of tokens minus arc from place to transition plus arc from transition to place. The new updated state you can obtain for every places. I can give you the one example here. Now you can see. Okay, before the pettinat, this is the graph basically. It is directed graph. directed bipartite graph. If you forget this marking, okay, it is very small graph, very small graph. Two places, only two transition. Okay, fine. But if you put the marking, it becomes the patronage. Okay, what is the initial state of the system is 2, 0. Okay, and I want to generate all possible number of states. Okay, how I can generate here? This condition is enabled or not, you can check here. Arc from T1 to T1 is 1, 1, token is 2, condition satisfied. New state, you can obtain that. What is the new state? 2, number of token is 2, that is a marking. Arc from phase to transition is 1, 2 minus 1 plus 1, that becomes 2. Okay, similarly, you can check here, is 0, initial token is 0, arc from phase P2 to T1 is 0, this is 1, okay, so 0 plus 1 is 1. So new state you can obtain like here, I can show you all here. If you fire T1, the new state is this. After firing, this is a new state, okay, up 2, 1. Before firing, the state was 2 and 0. Okay, if you again fire this state,
why is it 0 and P2?
here,
Yes.
I have taken 0, but you can take any.
Because T1 is coming to T2 and T1 is.
Why it is 0?
Yeah.
Why it is 0 here?
There's no
At initial marking 2 and 0. Initial is, you can assign any marking. It is up to you, that is flexibility. Okay, so after firing is this. So here the state after firing 2 and 1, again you fire T1, 2 and 2 states, again you fire like this. Okay, similarly here if you fire T2, this is a new state, and this is the all possible number state. Here no fight condition is enabled, that deadlock occur. You can use your concept, this concept in your cryptographic sense. Okay.
Token should be there as it is. There is no change in token or T1.
It is changed.
The second one.
This one.
Yes. One token is in P2, then also.
Yeah, the state is changed. 2 and 1. Here 2, 2. Here no token is here.
New token from it.
By the filing rule. This is the filing rule. State can change, maybe sometimes same.
The token can trace anywhere from.
Yeah, anywhere. So that is the thing, that is the beauty. Then for a given only this state, you are able to generate all possible number of states. So that means if you write some program, you assign some timing there, that means some automatic filing of the transition, you will be able to generate all possible number of states. That is the beauty of this. You write the program, okay, and you can also enter or stop somewhere. That is also flexibility. Just like in coding theory, whenever you want to secure some kind of network, you can stop it. That way, you must put some kind of counter, which can be treated as just like a deadlock. Okay. So another way is, can you find suppose this is the state you want to achieve, and you want to check whether this state is reachable or not from this state. Okay. So you need to fire. Okay. Can you answer the question? Can you generate or which sequence is optimal to obtain this desired result? Whether this one or some other way like this. Okay, so which filing sequence is optimal? That is another question. Or how many of them are the optimal sequences? If you file the particular transition to get the desired states, how many possible number of sequences, and out of possible sequences, how many sequences are the optimal? That is very interesting questions. You got my point? Okay, this sequence also written in this way, another way of writing. Okay, this concept can also be expressed in terms of the reachability tree. Same state you can express. This is the initial state. So here, all transition is fired by the state filing rule. So this is the state like this. You can generate. You can also express the information in terms of the reachability tree. This tree is for here, not a tree only. It is a reachability. Because this state is reachable, immediately reachable from this state, and this state reachable from this state, not immediately. This is immediately from this one. This is immediately from this one. This is reachable, this state. This is reachable by the firing of successive firing of the T3 one times and T2 two times, like this. Okay, so because transition are the actions. Okay, so how many ways, how many activities are take place? You can also check. To obtain this Usually in cryptography, some code is there, so how many trials should be there, so that the network should be secure, or other way, or network or can be cracked, or the particular core can be cracked. Like this. Several, you can have questions, you can have by yourself, you can ask several questions. Okay? Self-loop also very important concept. If self-loop means you can use this whenever you are modeling, for example, some canonical equations. What is the work of the catalyst? It never create or destroy. That means once the token here, token can neither create nor the destroy. It will remain same, always same. When you fire here, ultimately goes to here. Okay? You can use the firing rule. Same token will never change in that self loop. Okay? This is another representation, pre and post transition. Okay? Here, this example you can see T1 pre, how many places from connected T1, it has P1, P3, this is T1, P1 and P3 only, input place. Okay? Just another representation in algebraic way you can write.
T1 P2.
Yes, T1, P1 and P3. P3, mean input place, pre है ना, dot is pre, before T1, okay? Okay. Similarly, I can define the incident matrix I plus means arc from P1 to Pi to Tj I can write 1 if it is, otherwise 0. Okay. So this way I can define the incident matrix. Okay. Source transition, and second is the first one is sink, second is the source. Okay. So I'm coming here some kind of power of the patinate. Power means, you know, whenever you have sequential situation, okay, you can model with the help of sequential situation with the help of patinate. Whenever you have sequential, okay, that means this task can be started only whenever this activity completed. That is the meaning of sequence. Okay, initially the presence is here. It cannot be fire. It can fire only once it is fire. Fire means this token will move from here to here. That is the fire with the help of firing loop. You just write the program, generate your or simulate your steps. In Python you can use. Okay, I have you also use. So here, even fire. Before that, token movement here. Again E2 fire, token movement here. Again E3 fire, movement here. So in this way, we can model the sequential situation with the help of patinate. Okay, whenever you have sequential. Okay. Similarly, conflict situation you can model. Conflict means at this stage all transition enabled at a time. Okay, it doesn't mean that token will be distributed 1 by 3 equally distributed. No, it doesn't mean. Okay, because we have taken the token here whole number. Okay, so that means if E1 is enabled, okay, it is up to you. You can fire or not. The rest will automatically disable. For example, at a particular after 12th student giving the exam, they are selected in JE, medical or some other exam in NDA. Okay, so at a time they will get only one. Automatically rest will be cancelled or disabled like this. The same situation you can express in terms of the patinate. This conflict situation you can. Okay, once it is this, so token will not move pass from here to here, no deposit here. Only this will disable and token will move from here to here. Okay, if you fire a second one, in second situation, third one is third situation. Okay. Similarly, concurrency. At a time, you know,
Multiple.
yes, this is the main advantage applicable of the patinate in concurrency situation. At a time, token is here, or it move, it will be distributed. Initially, it is one, but after firing, it is distributed to all. It is not divided, but everyone gets one place after the firing. Here is 1, 1, 1. Okay, this is the situation. So here, all are enabled. So it is up to you. You can fire all the transition, or you can fire one by one. Okay, fine. So here the token will consume from the input, no output place. Okay, no need to deposit, but consume, token will consume from input place. If there is a output place, it will be deposited to the output place. Okay, like this. At a time, all fire, all firing you can see here. the token consume, if you perform all activity at a time, okay, token will consume like this. Okay, if you fire only one, only first one, the token will consume second one, okay, third one, like this. So you can model the concurrency situation. Okay, similarly synchronization, whenever you have a situation which is synchronized particular unit, so at a time or on a level, okay, the token doesn't mean 3 will deposit here, not necessary. Okay, only one, all it will be synchronized particular event. Okay, like this, like this. Okay, you can use this concept in your work, in your research. It is a one kind of machine learning. One kind of, it is can be supervised, can be unsupervised.
So remaining token will be lapsed in that.
Yes, yes, by the Fari rule.
Only one will be on transferring.
Yes, yes.
Remaining
We are using the Fari rule. That is the beauty of this concept. We are using Fari rule.
Because in earlier one,
Yes.
they are getting the.
Yes. This is situation we can handle easily with the help of pattern. Okay? Mutually exclusive also we can handle here. At a time, suppose this is a loading, this is unloading for example. At a time, for example, you are loading and unloading, some track is there or robot is there. At a time you can load and unload. If you have more than one robot, you can also do it. Okay? Suppose this is a single one, this is enabled. The token will here, it doesn't mean it will be shared. If it is loading, so that means rest will disable. You cannot unload. If you are unloading, you can unload. Okay, like that. I have not given you. Another example, patinate you can use in cryptography. I will also give you some more example. You must till now you have some idea. You can implement our idea in those situations. Okay. Not limited. Other you can also explore. Can be used to model behavior of the cryptographic protocol, because right now we have discussed the behavior, how the state change one state to another state. You can use in secure socket layers. Okay, you can fix some transition when a deadlock or no deadlock, because other property also that are not shown here, that is liveness property. Okay, or boundedness property. Bounded as this, you can make the unbounded system to the bounded system, or absence of overflow you can model with the help of patinate. Okay, so here in that situation you can use protocol often involve several stages, steps, or message changes, and the patinate are ideals for visualizing and formalizing these stages. You can use. Good. Okay. और detail मिल जाएगा आपको. I have given some references. You can check. Okay. This is another attack modeling distributed cryptography in the blockchain. Lot of application, lot of article has been published in this, by using this one blockchain. Okay, not blockchain. Okay. Behavior property, structure property you can use. I just giving you some example here. Boundedness means if you fix some token, okay, k number, so that patinate is place is called k bounded. If it is true for all places, the patinate is k bounded. Okay, so I can show you one example. It can be used in absence of overflow. And here, this is the patinate. If I consider the reachability of this, okay, and if I generate all possible number of states here, so now you can see it is a 3 bounded. Okay, nowhere you can see the token more than 3. This patinate is 3 bounded. Okay, so can you characterize such kind of codes or layers? 3 means it can be firing of 3 times, firing of 4 times. So how many try one should make so that to get the desired code or some reachable state. In this way you can convert your statement in your fix in your as per your problem. Okay, it can be possible. One bounded. This is another very important example. I have worked a lot in this. Okay, now shape means the token either 1 or 0. Okay, so now we are dealing with the shape system or binary number system. Binary number system. Okay, you got my point? Now, this is example for the shape system. You can model the traffic light system. I have assumed only one traffic light. Okay, so how many colors in the traffic light? 3 colors are there. So every place can be taken as a red colors. And the start of the yellow or red or green can be taken as a transition, because transition is activity. Okay, so once that red light is showing here, the red light token means the red light is going on. Okay, whenever this start of green, some activity or filing some condition reached a particular level threshold, then the token will move from green. That means now red light change to green and to yellow. Same way you can model even daily traffic light. This is one kind of project you can do. If you have the data, if you set some counter here, you can assign some time t equal to 0 to any time. You can optimize the traffic flow as well based on traffic intensity. Very applicable. Okay, like this. This is also liveness. Liveness means transition never be dead or deadlock occur. Okay, you know the system in our seasonal system continuously work. Okay, so now conservation also, whenever token sum before filing, after filing same, that property is called conservative property. Okay, so now another property is that related to linear algebra. If you know that property is called here P invariant and T invariant. P invariant depend on the places, T invariant depend on the transition. Okay, so here P invariant is a vector. You may place P with these conditions. This is the marking vector. Okay, if you use 0, that means the incident basically incident matrix. I told you I plus I minus you can generate. Okay, if you use here, so what is the application? Identify set of places. By using the P invariant property, you can identify the set of places those are connected with the transitions. Okay, what is the property? Where the token is constant. Okay, if you are able to find that is called the P place invariant. Token sum remains same because you have n number of transitions, m number of m number of places. Let us suppose, and out of m and n, and you have some x number of places. Okay, where the token sum is same, you can identify. Okay, with the help of this. This example is also given here. Transition means identify the set of transition to fire from one initial marking to return the the given marking. Okay, you can also use in several ways. Some without changing the overall state. That is another property.
Pointer is
anyway, circuit is also 3 basic property and mostly used biologists also using. I have also used in tuberculosis disease and cardiovascular disease. We identify some genes basically, some potential genes we identify. That paper already published in tuberculosis journal, very good journal, high prefix journal. We published recently 2024 that article by using these only 3 properties. Okay, this is the interpretation. Places can be whenever you are modeling. Buffer, channel, geographical location. Transition can be transformation, transportation, task, job. Token can be any human, goods. For your interpretation, just overview. Okay. Some other application, if you love chemistry, let us suppose. Okay, I have taken only 3 questions. I have taken this example from Google. Okay, but I model n number of equations. Okay, this is for only illustration point of view. The equation can be taken as a transition, and the molecules, atom can be taken as the place. Okay, and token represent the molecules or atom is present. It is not giving the actual amount is present. That is giving the presence or absence only I have taken. But if I use the continuous pertinent, you can put the actual amount. That is also possible. Okay, so here dot means presence. Then here carbon and oxygen, whenever they combine each other, they release the carbon dioxide gas. Okay, the token will consume from here and this will deposit here. It is a situation of the synchronization. That concept I am using, synchronization concept. Okay, subnet effect of it. So now token, now CO2 with you, and then CO2 combined with NaOH, that release NaCO3. Okay, this equation you can model like this. Okay, n number of equation. Whenever you have n number of equation, chemical or biochemistry equation, it is not easy to understand or model, but visualization you can make the visual effect. Also you can check several conditions. P invariant you can check, T invariant, other property you can. Okay, that you can use the graph tool directly. But indirectly, if you use this just like a directed bipartite graph and initial marking that become the pertinent. You can have several informations you can generate. Okay. One more thing. Then after that I will switch to application of binary, or I will come back here again. Let me show you some other applications. I will come back here. Okay. Computation also possible. Otherwise, this is also okay. You know the BFS
Yes.
and DFS. Okay.
Yes, sir.
So you know, if you use the pertinent, you can smoothen. You can redefine or revise your algorithm, and maybe you can reduce the computational running time, or complexity you can reduce by using the pertinent. Okay, because now you are using pertinent as a machine learning tool. So here, trace can be vertices. You know the breadth first search. Okay, it is also, I have written 3 lines as well. Transition can be visiting a node or transitioning along an edge, and this represents current state. BFS you can model. You can study BFS algorithm or DFS algorithm with the help of this pertinent concept. Just defining, taking the place and transition like this. Okay. This is the DFS. Shortest path also this kind of interpretation. The assigning. Okay. Graph curving. You know the graph curving. The very beautiful application of the bipartite graph. Curving means you can color graph or vertices, assign the vertices, color the vertices such that no adjacent vertices receive the same color. Same color. Okay. So based on this, we have 3 color theorem, 4 color theorem. 3 color theorem means we can map the entire, we can color the entire map with minimum of 3 colors. Such that no common boundary, they will not have, they will not assign the same color. Adjacent one. Okay? That is a very important theorem proved by the graph theoreticians. Okay? A lot of applications. Spanning tree, we can also use Prim's and Kruskal algorithm. Okay? So now here, the application of cryptography application. So here I will explain the concept of lattice and Boolean lattice basically, with the help of the Boolean and crisp Boolean pertinent. This is a research, new area of the research. Okay. So here, although I worked a lot on this, but it's still a lot of scope to work in this area. Boolean and crisp Boolean and the binary pertinents. Okay. These two depend on the behavior of the pertinent. This is totally based on the structural property of the pertinent. Okay. And on this topic, one thesis already awarded on this. This is already 2 theses awarded, and we are not able to characterize full. Okay, even lot of scope for the research till now. Okay, so now Boolean means this is a Boolean, this is a crisp Boolean. Boolean means a pertinent which can generate all possible number of binary vectors, possibly with repetition. So this is the pertinent that can generate all possible vectors, binary sequences, okay, possibly with repetition. It has 3 places, 2 raised power 3 vectors it has contained as its regionality, in its regionality as a marking vector. The first one is class is called the Boolean pertinent that we define. Second is a pertinent which generate all the binary and sequences exactly once. That is called the crisp Boolean pertinent. You got my point? First is repetition allowed, second repetition not allowed. That is called the crisp. Okay? It works in general. It works for a specific class. Okay? So like here, the idea, how we got the idea. You know the graph which is star graph. You know, this is the star graph. The idea coming from this star graph. This is a basically K1N. It is a bipartite graph basically, in which one partition having only one node, second has n minus 1 node if total number of nodes are n. Okay? What we did here, we have taken the vertex center as a transition. This is also transition. This is also transition. we have taken, okay, and we subdivide this edge by the place node, okay, and we have given the orientation towards the transitions, for everyone, transition like this, okay, understand? And we fire out the transition and we prove mathematically that there is a patinate which is the Boolean image that generate all possible sequences possible with repetition. This is a Boolean patinate. Result already given, already published, what is there. This is the published one. Okay. This is also disconnected patinate. That is most very important result. Logically, what we did here, we remove that central transition from here. That, and we have n component and disconnected component like this. Okay. And we fire the transition. Okay. If you fire the transition, I'm not giving you here. We also given some theorems. This is another patinate that generate all binary sequences exactly one in the first step. Okay. The previous one is not the first step. Okay. It is the first step. It is a minimal. It is also unique. We prove it. Okay. First step, we have all the binary vectors. So now this is also, we have all binary sequences with a minimum number of firing of the transition, not minimum transitions. Okay. The previous was not the minimum number of step. Okay. That is called the minimal patinate. And this is the minimum number of transitions. Okay. Not the minimum step, minimum number of transitions. Okay. There are two classes. And this is a minimum number of transition. Okay. I'm coming here when you go theorem. Okay. Another applications, we use this concept in multi-function or multi-switching. We can model this concept, use this concept. Okay. So here, this is the patinate same, and if you fire here, so we obtain this basically. Okay. So that means with the help of patinate, we can generate like here. You have see this one. This is the reachable tree. If I fire out a transition, this patinate, 3 transition phases, and I will get this. This is a reachable tree. Okay. It has all binary sequences. Repetition is there. It is a Boolean. Okay. What I'm going to do here, I'm going to obtain the homomorphic image of this reachable tree as the complete Boolean lattice. Okay. So now I can generate the complete Boolean lattice with the given reachable tree. How I can generate? I can show you here. I can label divide the partition. First one I have taken P0 1 partition, P1 1 here, and the Hamming distance is 2 from the initial. You know Hamming distance, number of positions they have different. They have taken here same marking. You have put in the same partition. Suppose V4, V6, V4 and V6 same marking. I have put in the one partition. Okay, like this. Fine. So I have taken again every partition as a vertex. Okay, and I can join those partitions. Those are connected here. Okay, so if I join like this, I will get this one. Okay, so this, you just tell me this one and this one. Both are same or no?
Yes.
Both are same.
Yes.
So now this is nothing. This is the homomorphic image of the natural tree that can be obtained if I fix the marking. Complete Boolean lattice. Okay. So now advantage is that you can increase the dimension of the lattice, or you can also reduce the dimension of the lattice. Okay. You can also map the vertices by the different several information you can store, because marking is n component it has, and you have 2 to the power n number of vertices. Okay, exponential vertices you have. Also, every vertex can be mapped as a you can store n component information. Okay, so that will help optimize the cloud computing if you are talking about the storage program. Okay, that is a very beautiful example. Application of this kind of work, cryptographic applications. Okay. Similarly, if you have 4, okay, so now you can see this is the lattice, Boolean lattice, complete Boolean lattice. Boolean means Boolean may be complete lattice. It is a 4-dimensional. N-dimensional means 4-dimensional. If you take n equal to 4 places, like this, same situation, same we can have generate. Okay, so here that is a very beautiful application. Same concept we use here some other sciences. In finance also we generate all possible number of states. I'm not giving here the details, but it can be implemented. That one I already published from our lab. Okay, is that fine now? So now I wanted to show here some application, some live application, live demonstration with the help of the software. That software I can show you here. Now you will see here how the change occur drastically if I make change even in one dot, one marking, one token in a place node. Okay, that I wanted to show here. You just see that we have also written some kind of coding in way. Okay, so now you can see this is the place node. I just okay, this is the transition. Again, this is the place. Okay, and here I'm taking this one transition, and I'm connecting with the arc. Okay. This is one. Okay. So now if I add some token here, let us suppose if I taking one token here, let us suppose. Okay. Let me run this. It is automatic simulation here. Okay. You can write code in that will be good if you write your own code. Okay. Under some circumstances. So let us suppose if I run this. Okay. Run this. Now you can see the change. This is the statement. Okay. Now let me take the sensitivity analysis. If I increase the one more token here, if I take one token here or here, let us suppose, and if I run again this, now you can check. I'm not sure whether program will run or not. It is running, no problem. Okay. Let me check. Take one more token or make change one more, or increase one more token here or one more here. So now what happened here? Now you can see the slightly change in the token. You can see. Okay, understand? And I can also show the lattice, how you can generate the lattice here. Let me remove this one first. This is and this is and 3 transition. I'm taking the same pattern that we defined. Okay, now tell me how many tokens I should take here? One more? Okay, one more. Fine. Okay, now we will change, make a little change. Okay, so now you can see
It's showing the moving of tokens.
yes, moving of tokens. You can see this is the state. If you click here, you can see the marking state, and after finding of D node, this is the state. Finding of D1, new state like this. Okay.
But all the places are not connected to this. Only all the single one are there, no?
Yes.
The graph.
Yeah.
So no.
It is a rigidity graph.
There's no connection between two places or two transactions.
Yeah. But it is not a pertinent. It is a rigidity graph.
How they are connected to all the.
By the firing rule. Rigid tree basically. Tree means.
They should be connected to it. Then we will move to all the
yes, sir.
places.
Yes, yes.
Then there is no connection between all the places and transitions.
I mean, that's fine. But every place has to be connected to transition. That is possible. But if you have component place to place, one subset, second, that is also a pertinent. Okay, isolation नहीं होना चाहिए. Okay, place is there, transition has to be there. Transition is there, place has to be there. Okay, like this. This situation is possible. Or this transition, or this is the place, this is possible. But I cannot have the place or transition isolated. This is not the pattern.
But all the places are not connected to each.
This is not connected, but this is the pattern.
So all the token will move only one transition or all the places.
The token will move as per the state change. Suppose if you fire this one, token will consume here. What is state? If it is 1 and 1, if I put direction like this, 1 is 1 1. If you put, let me explain, 0 1. If you put here 1 0 like this.
There should be connection between two transitions.
Yeah, they are connected.
But they are not connected in the
I mean, here is not connected. Here is
so how
not
they are
connected.
moving to all the places?
By the firing rule.
There should be connection between two.
Yeah, firing means if you have the new state, you join that one right there. Okay, that is a relation, inbuilt relation by the firing rule. Okay, and arrow here we are writing the transition that shows that this state will obtain after the firing of this transition. Although this is not connected, that is another beauty. Although network is disconnected, but graph is connected.
That's all.
Got my point? Even though you have disconnected pertinent, but you will get the n-dimensional complete network. So let me put this. Okay. एक मिनट और माय डियर कलीग्स एंड एक और देखो अगर मैं एक टोकन में चेंज बनाता हूँ only one take make the one change in one token, so now you can see the changes. देखो change the okay, and if I again further increase in one more token or one even the one token single token, even the network is disconnected here. This pattern is disconnected. Okay, so now you can see the change in the state that will increase exponentially. Now you can see. So whenever you are lattice type structures and data mining, you can use this. Okay, if any question you can have closing this one. Okay, but this is a very important area.
सर तो ये फाइनाइट ऑटोमेटा का क्या पैटिनेट से कोई कनेक्शन है?
Finite actually it is a updated version of you can see automata. You can see. Okay, but in automata the reachability other connections not possible. Okay, you have in some kind of states, but here you have a network. You either connected or disconnected, can be any, but you can analyze several other properties. Okay, but in graph theory, ordinary and the automata, it not possible. This not possible. Okay, several properties are. You can use almost in all areas. Automata may not. Okay.
Thank you, sir. Thank you for
Yes.